Wow.
Okay. Hi, everyone. Here we are at the last session of this nice Blender workshop. I hope you arrived here and you could follow all the previous lessons. One small comment, practically for the lesson of today, we will not need only like few concepts of the previous lesson, but what we are going to do today is practically completely different from what we did. So today we are going like to really color our scene, light our scene, and render our images. And so practically everything will be slightly different, and so you don't need previous concept to understand this lesson. Another thing is that the lesson of today will be the heaviest for your computer. So I will let you know when to do some action that can be critical for you, for your computer, not for you, because sometimes it will be like really, really heavy. I mean, we are going to really push the computation. Okay, said this, what we are going to do today, as I said, is like trying to understand how Blender can really give color to our objects and how it calculates all the, let's say, properties of our object and how to give some properties to our object. What I ask you now, if you are in this scene here, is directly to try to do one thing. Until now, we only tried to see what happens if we are in the wireframe mode and the solid mode. That practically the wireframe mode showed us which are the, let's say, inside the different meshes, and showed us like practically the edges and the vertices of our objects. Solid mode practically only showed us the flat object with the faces, but everything is flat. And today we are going to explore these other two modes of Blender that are the material shading and the render shading. In the material shading, if you click in the first one, there is a preview of the material that you're going to use. So it's like not like truly the material you're going to use, but you can get an idea of the materials. And in render, there is a preview of the last image. If you click on render, as you can see in my screen, practically what happens is that everything is black. And everything is black because we don't have any source of light. Blender is practically a software that is, at this point, after building up all the mesh, after setting up our 3D scene, is going to calculate practically which are from a light source is going to emit light, and that light is going to interact with our meshes, and depending on how it interacts, it will bounce, reflect, be absorbed, transmit from objects, and then at that point it's going to arrive to our view. So if there is no light, we cannot see anything. So this, we can directly start adding light to our object, and to do that, you do it as you add the mesh, so Shift A, and you add a light that is here in this panel. And the most basic light to start is the sun. When you add a sun, practically you're adding a light that is coming from infinite, let's say from the infinite, and all the rays are, let's say, parallel one to each other. If you see, if you bring it up, grab Z, your light is here, and the direction of the light is this green line here that you can see. So if you, for example, take these dots that is on the line and you start moving it, you can see that the shadows changes depending on the direction in which the light is coming from. In the panel here on the right, there is a small lamp, and here you can find all the properties of the light you're using. For example, you can increase the strength of the light, you can change the angle, and actually for a sun is this, because there is no much properties you can do. I mean, there is a how much light is coming from the infinite and at which angle. That's it. The typical problem you have with the sun is that it's practically making very sharp shadows, as you can see here. And the sharp shadows are because practically because the light is coming from the infinite. I mean, it's too long to explain. So the way you solve this, I mean, sometimes it's good to have sharp shadows, sometimes no. And if you, instead of using the sun, you try to use, for example, the point light is shining light from a single point isotropically. So you will have like from this point here, the light is coming as a sphere. And typically the power that you have to use for a point or area light are 1,000 times the amount of light you have to put in the sun. So for example, here, instead of 2 watts, I mean, I don't know why it's watts, and I don't know if it is a true value, but it's watts. Instead of 2 watts, you can try to use 1,000 watts, and you can see that now your image, it looks like bright again. And but it not only looks bright, but it also looks, in my opinion, a bit nicer. Now, you can still notice that the shadows are still very sharp, and this depends on the radius of this point. So practically, a point light is a shining light from a single point, or depending on the radius here, you can expand this point, so you can distribute the power that you put in the light in a bigger sphere, let's say. And with this bigger sphere, you can, let's say, adjust the shadows that you have in your scene. So for example, if you increase now this radius value, you can see that the shadows are doing something kind of weird, but they are smoothened out. Okay. This thing is that what we are using is a rendering engine that is not made for static images, and then I will explain later. And I will explain later. I don't want to enter to this thing now. So here there are 2 big parameters that you can change, that is the power and the radius. Here you don't have any angle because, as I said, point sources are isotropic. The last thing that is important is the area. The area is shining light from a plane. And then practically this is actually very useful, and it's very used a lot in photography in general. So you have planes around your scenes, and depending on how you put planes, you can set up different lighting of your scene. For example, here you can, now since you have a plane, you have a normal to the plane, so you have a direction that you can adjust again with this dot here. And again, you have a size, and depending on the size, here you can choose how big is the plane that is emitting light, and you have the power that is distributed on the plane. So if you do 2000 now, your scene is brighter and your shadows are really, let's say, softened out because the plane is like huge, it's 24 meters here. Before going into the detail of all of these, I would like to ask you to go in the test scene, because I would like to really start from a scene that is as easy as we can. So my voice will not lag, because when we start to color these scenes that are full of objects, full of vertices, etc., probably the Zoom call will lag a bit. Typically it does this when I call friends to show my stuff, it's always lag. So let's go again in the test scene here, and let's add some basic objects. Let's go in solid for a second, and let's delete the graphing. Let's add a plane that will be like our temporary background. Let's scale it a bit to have like a big background, and then let's add a cube, and let's bring the cube above this. Also better to add, sorry, wait, I forgot to open the screencast tool. Okay, let's also add a UV sphere and grab X here to have a comparison. And let's again go in rendered view. Again, there is nothing because we have no light. Let's add some lighting. Let's set up an area here. Let's again put something like 1000. Let's duplicate this area. Let's put it on the side, and let's center it on the scene. We scale it to 20, let's say, and we increase the power to something that makes sense, like 5000. Okay, now we see that we have shadows in this direction that are softened by this top light. And then you repeat this action on the other side. Okay, so here we really should have a decent system. As I told you before, here the shadows looks kind of weird, and there is the way to make it nice in this engine. It's called rendering engine. But to actually see which is the rendering engine, you have to go here in the render properties. In the render properties, you can see that the render engine is called ED. ED is typically used in video games or videos. Practically, it's a real-time rendering, and it's performing a simulation, but it's not accurate. It's not photorealistic. To have photorealism, what you have to use is cycles. Cycles, what it does is really performing a ray tracing simulation. So you have your light is going to your object, and really the cycles engine is going to calculate phase by phase, which is the reflection, transmission, absorption, and all the properties that light have when bounces on objects. And now we are going to see how to change those properties. But it's in cycles, you have photorealism. So it's like taking a picture with a camera of a fake real thing. Another suggestion that that I have for you is if you have a GPU, use it, because Blender now is going to do vector graphic, and if you have a graphic card, it will fasten like n times, depending on the graphic card you have, sure, this process. So if you have a GPU, please use your GPU. What else? Okay. So again, only to conclude on this topic, if you have to render a video, it's better Eevee because it's faster, but it's less photorealistic. If you want to make an image that is nice, it's better to use cycles. Okay, so let's start trying to go in the details of our materials. As you can see, everything now it's plain. Everything is white, everything is the same. To change the material, you have to go in this like sphere here with 4 quadrants on the bottom right, and it's called material properties. If you go in the material properties, you can see that now there is nothing because we didn't set up any material. So if you click on new material, it opens a new panel with a lot of properties. I will talk about only the, let's say, the most important one. I will not go really in the detail of each of these, let's say, property here. So the material we are adding, it's called principal Bsdf. And principal Bsdf is the most general material, and it's taking into account everything. It's practically really, you can create more or less all the material you want with the principal Bsdf. There are some specific material, and you can see those in the, if you click on principal, there are a set of pre-made material that are actually, there is no, let's say, gold, there is no water, there is no something particular. For example, there is glossy, that is a metallic material. So if you have to make gold, you have to set up the glossy as you want. So this is important to understand that there is no material that are set up by Blender. You have to have your set of materials. Today we are going to build a decent set of materials. And every time you want to, let's say, open a new Blender file, you will have your set of material already set up in another Blender file. You can import the set of material, you have your own set of material. So let's start from the principle. As you can see, there is the base color, and you can imagine what the base color does. The base color is the database to find these values for any material we want. What I typically use is YouTube videos. I write how to make this, and typically I find it. In principle, there should be, but it's a bit advanced. What, let's say, people does at like advanced level is texturing. So instead of having to setting up a material, you do it with other softwares, and then you, let's say, wrap the material. I mean, it's kind of weird, and I don't want to enter in this detail. But the real answer is, I don't know. I have my own, and it works. And if I have to make a new one, I think to the physics of the material I want to make, and I typically can make it. Okay, base color is easy to understand. It's the color of the material. Subsurface, subsurface radius, subsurface color, subsurface IOR, and subsurface anisotropy, we don't care at the moment. The subsurface is practically actually heavy also, that's why we don't care at the moment. It's practically what happens when you shine light on your finger. What happens is that you see that your fingers start to be reddish. And that's because the light enter a bit into your fingers and then scatter inside the finger, giving a different color to your skin. And that's what it does. So it's like setting up a different color when the light is a bit inside of the material. This is very useful for organic stuff. But at the moment, I think that the best is to not really care about subsurf because it's really longer. So these things are out of the scope of this course. Let's now go to metallic. And I think also this is intuitive. Metallic is practically the reflectivity of your material. You can increase the reflectivity and this value goes from 0 to 1. So 1 is 100% reflect 100%, and 0 is not reflecting anything. Here it's not really evident, and you always have to understand that the material has a perfect lighting scheme. So if you want to really have like let's say the view you want, you also need to shine the proper light. And you can observe what's happening if I start removing some lights. You see here that actually you don't see it very well, and I explain you now why. But this material, I tell you, is reflective. Specular tint, again, not really important to make a nice material. Roughness, yes. Roughness is practically considering each point on the surface, and it says practically each point is diffusing light on top of your surface, and if you have a roughness of 0, each point is not, let's say, exciting close point and is doing what you tell him to do. If you increase the roughness, you practically say to your material that each point actually scatter light to the closest point. Okay, so if you can see that if you reduce the roughness to 0, you really have a shiny object that is reflecting perfectly the light that is coming. So if I now add the light again, you can see that maybe you can see that you can see object reflecting to your object. And this that we have here is the setup, 0 roughness and fully metallic, is the typical setup that you want to use for a mirror. A nice mirror has always, I mean, 0 roughness is something that looks physical. Typically, I never use 0 roughness. I always use a bit of roughness. But this is already a very nice mirror material. Then roughness and metallic. So let's again reduce the metallic to 0. And you can see that the roughness is actually giving you again a different looks of your object. So now the object is only diffusing, it's not reflecting. And again, how much it diffuses depends on the roughness of your material. Pay attention that the roughness here is not real roughness. So it's not that your surface become noisy. It's that your surface become more uniform. Okay, that's a slight difference, and later we will see how to really make real roughness instead of this roughness value that is not like really physical. Okay, let's again keep the roughness to half as the beginning. And here there are anisotropic sheen, teeth, click coat, and all of those from anisotropic to clear coat roughness. I will not talk about them because, again, out of the scope. I mean, you can improve some material, but they are not really drastically changing the material. What we're going to see now is IOR, index of refraction, and transmission. If you increase the transmission, I mean, again, intuitive, your objects start to transmit light. And if you try, for example, to increase the transmission to 1, you can see that your object is transmitting light, but it's not very well transmitting light. It's not like nice glass. And that's also because of the roughness. Here, if you want a nice transmitted material, you need to have the roughness that goes to 0. At this point, your material is really a glass. So actually this one, transmission to 1 and roughness to 0, are the typical material you want, the typical properties you want for a glass material. And only to let you know, I mean, here, let's also give this, if you click on another material, here again in the material properties, if you click on these balls here, you can select material that you have already used. So for example, I can give Control Z, I can give the same material to the sphere. And let's also make it white. And this is a decent glass. I mean, it works very well as a glass. You can also right click and shade smooth to have like a smooth surface of the sphere. And what I want to tell you is that now we are doing a simulation. Okay, so we have focusing of light. We have, let's say, for example, a very easy thing to see. But if we add a cylinder, for example, this is a, don't do it, it's only to show like an easy thing. For example, if we take an arrow, sorry. And we put it behind our glass. What is going to happen is that if I look at, I mean, the arrow is pointing in one direction, and really, if I go in the view here, I see through the glass that the arrow is pointing in the other direction. And depending on where I put the arrow, this direction here, I can focus on the arrow. You see this weird, let's say, look of the glass, again, because of the lighting. Okay. So let's again stop the transmission. So this is for glasses. And let's talk about emission. Okay. The emission of light is can be actually also added to objects. So there are not only lights that can put light on the scene, but also objects. So for example, if you take the color of the emission and you put it completely white, you can see that your object is now bright because it's emitting light. And if you increase the strength, you can see that now you have really a lamp as an object. So you can always use object as lamps if you want. If I don't typically like them, object as lamps, but there are, let's say, also people that does this. So this is the emission for now. And the last thing I want to, let's also bring this to 0. The last thing is alpha. The alpha is practically a kind of absorption coefficient, in the sense that it's evaluating how much light is going to interact with your object. And this is kind of different from transmission, in the sense that here you can make transparent object, but because practically not all the light that you have on your object is interacting with it. There is some light that is passing through, and this is like the percentage of the light that is passing through the object directly without considering the index of refraction or anything. So for example, if I decrease this alpha, I can see that this object starts to be transparent, but it's not as before. Now I see through. That's it. There is, I'm not making glasses, I'm making transparent-ish, like shadow objects, okay? And if you want to make a real transparent object, alpha goes to 0 is the way. Instead, transmission is like to consider that the light is passing through the object, is bouncing inside the object, depending on the index of refraction of the object, and then it's going on the other side. Okay. So these are the very, 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 very basics of materials. So this is, you can play with those to make a kind of decent material. For example, if I say that I want like a kind of golden material, I can directly say that the alpha, everything should interact. My object needs to be very metallic. And finally, that my roughness needs to be a bit, not that much, like 0.1 is nice. And you can see now my sphere is really a nice metallic sphere. Here you can choose a base color that looks like gold, more reddish maybe. And yeah, you already have a golden material. Always when you make a material, remember to name the material. So for example, this one here is gold, and we will use it later, okay? So for example, we can use it to set up the scene for the nanotube that we have. Okay. Another material that we can make, it's we can remove this material, add a new material, and call it glass. And as we said, the glass is nothing more than a fully one transmission and 0 roughness. And this is already, let's say 0, it's always too much, 0.05 roughness. And it's already a decent glass. And again, we're going to use it, for example, for the glass slide that we have on the other material. And again, remove and add. Here, we can try to make, I don't know, a laser. And our laser need to be, let's say, emitting, let's say, red light. So it's full emission, a lot of emission at 10. And this can be our laser. We reduce the roughness, or instead of this, if you want a pure emitting material, because this is also reflecting light, a pure emitting material, you do it instead of using principal Bsdf, you take the principal, then you go to emission. And the emission is pure emission of light. You see here that now this is a ball of light. And let's call it laser for now. Again, let me go 1 second on the other. Here we have to set up metallic material for the objective, metallic material for the optic table. This one can have the laser can have the laser, and the glass slide here can have the glass. And for the moment, I think that's it. We don't have any other particular material. Okay, for example, we want this one to be to have an emission like the laser, but of a different color. So what we could do is to set up a new material, or to take the material of the laser and to click here on this number. I don't know the number precisely what it means, but this means if you click here, you're practically saying copy the material you have and call it in another way. So if you now go in material preview, you see that the two things have the same material, but now if I change this, I'm changing only this photon here. So let's say that the photon, we do kind of an up conversion, and the coronavirus is emitting violet. There is some lines of the coronavirus. Alfredo, you should know now. Is interacting with the visible. No answer. Okay, I don't know, so let's make it violet. Tough question, yeah. Let's make it violet then. Make it green. Okay, cool. Take it green, and we also decrease a bit this value. Okay, and now our laser is exciting our coronavirus and is emitting a green light. Still, I'm not in the rendered view because otherwise probably it will be heavy and I will start lagging. We will see like a few times in rendered view this scene. Okay, now I want to color the coronavirus. And to color the coronavirus, I need to color the sphere and each object. Since if you saw the last lesson, you know that we add all the object as a particle system to the sphere. And then all these objects, all the details of this object are enclosed in these three basic objects that we set up. The cool thing is that to color all those objects, I need to color only the basics, the basic object that I use as a particle. So if I, for example, take this, I give a new material and I make it red and kind of low roughness, I already have the same material all over the coronavirus. If I take this guy and I make it yellow, I don't know, this is really random. And again, low roughness. This is, let's say, green. My coronavirus is already nice and colored. For the ball, if you click on the ball now, you see that if you change this material, you're changing material only of the ball, because the material of each particle, now let's call it properly, of each particle is encoded in the basics object. So here, again, let's give it a grayish color. If you have a particular color that you want to give, this is a RGB, hexagonal, and a HSV values, so you can directly put the values here. Or let's say you can here, let's say, give it a grayish color. like this. Okay. Our fiber will be, again, can you write a RGB code?
For define the color.
What do you mean?
To define the color.
Yeah, sure. I mean, if I put it here and instead of the color here, I put like 0.5, it starts to change completely. So if you have a precise value for your RGB, you can put your RGB, you can put hexagonal and you have like directly the file. So you can find your color on internet, the values of your color, and then you can directly put it. This one should be, let's say, similar to a glass, let's say, but to make it like a bit different, let's increase the index of refraction. Oh, sorry, I changed also the previous one. We need to make a new material, call it fiber, and we can increase it. So that was nice to have a high index of refraction and a bit more roughness to the material. This one here, it's a metallic material. So in principle, we can use the gold, change it, take a new material from gold and call it objective. And instead of yellowish, we can make it, let's say, of this color here, grayish. And this one, we can take the objective. And again, since it's kind of metallic, I would say that for the optical table, we can use an even darker color for the metallic and a bit more roughness because the optical table are not that shiny. So we can increase the roughness, but keep it metallic. Okay. Now I want to talk about different material on one single object. For example, let's say that I want to color this line in the middle of the objective in a different color, blue, and not metallic, because there is a line in my personal objective. So, for example, I can try to add a new material that goes below, define it as a blue line without anything else. But I can see that this material is not applied to anything. So how can I, let's say, put a material on a precise region of the object? So you can do that by going in edit mode and selecting precisely the face that you want to color. For example, if you take with Alt, with face select mode, Alt select here, you can select the line here with Shift Alt select. You select these two lines and you say here, you see that it appears an assign thing. So you clicking assign, you can put the new material on a precise region of the object you have. So this one, you can do it. For example, we saw that the object here was yellowish. So let's make it gold because we are rich and we can. Not, sorry. Let's go here for a second and let's also remove this display. For who wasn't in the previous lesson, is showing you like showing the modifier or not showing the modifier in the view you have. So if you now go in edit mode, is not displacing, so the surface is not interpolated and you can see all the faces. So Alt on this line, Alt on this line, on this line, and on this line, and in the material view, you can add a new material, make it gold, and assign it to this part. So now, if we go in material preview, our objective is made like this. And this one in the center, if I remember, was actually, let's take this objective only. This part in the center was a blackish material. So we can select with as you prefer. I will do it with a circle. You can select all the faces here. Maybe a bit more also. So those one. And actually I'm selecting what the thing, right? So click on one face. So you deselect the one that are out and reselect everything. Add a new material. Let's take the material 4. It's actually not a good idea to have the material 4. Because I'm in edit mode. Let's remove this material. Add a new material. Make it black. Go in edit mode. We have the face selected. Take this material and assign it. Okay. And now our objective is made with different materials. Okay. Let's click Alt A and show again everything. Now we have made more or less the full scene. And we can try to look at it in a rendered view for a bit. I don't know if my computer can do that. Here we are in Eevee, so it's still fine. If we go in cycles, it's still, yeah, I can see that. Again, it's kind of ugly because our lighting is still not properly set it up. But you can see already that our scene is already kind of nice. One thing I suggest you, because I'm not using the GPU. I would suggest you to add, because once I did it and it looked really nice, is to duplicate your fiber. Go in the properties of the curve that was here and reduce the depth to a value that is a bit smaller, and add to this new fiber the laser material. So now once you go in edit mode, I gave it to the whole fiber, sorry. So this one should be 5. Oh no, it's fiber, okay. So let's make it smaller, maybe it was nicer. Okay. You can see that it looks like there is the laser going through the fiber, and you can adjust this laser inside the fiber by adjusting the depth of the size of the inner part of the fiber. Probably is also because there is not enough light going in. So let's set up a decent lighting. Again, let's take another area and let's put it kind of here. Let's choose a view, because that's actually very important. And I would say that this view here is okay. And let's increase this value to 5,000, maybe also 10,000. And the value of this other light here, again, to 5,000. I would bring it a bit down. Here you can make your own and you can find what fits best in your scene. I would say that we need a light also to put some, I mean, here we don't have any lighting on the back of the objective, so it's kind of ugly. And then you can duplicate this, bring it Shift Z and bring it behind the objective and let it shine on the objective. So now, in principle, you should see some details of the objective also very well. And yes, let's say that this is a decent setup for lighting now. While now we can go on the also setup of materials. You can go in the nanotube session. We can take all of our contacts and make it golden because we already have the gold. All of them are gold, 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 gold. And gold. If we now try to look, yeah, it looks okayish. Again, we are in EV, so it looks okayish. Now it looks more okayish, more realistic. We can see we can set up our SI2, for example, again, that use the GPU always. That is a reflective material again, but instead of yellow, we make it purplish. And then we should set up the light for having something nice again. What we can do is that if you have a nice setup in another scene, like this one, you can take it, let's go back, take this, copy, paste it in the nanotube, and it's already nicer. Maybe we can rotate it to make some nice thing here, but yeah, for now, let's keep it like this. We should have like maybe more diagonal coming from here to shine light on the gold, because you can see that with this setup of lighting, we are on the nicest part of the gold is on the bottom. So maybe if I can grab Y, oops, grab Y. Yeah, this is already nice. I mean, here you have to adjust a bit to have like your own lighting set. But this, for example, already look really, really okay for the moment. So with all we did now, you can already have nice images that are already a bit up compared to whatever you can do in a 2D software, at least correct me if I'm wrong. I want to talk about like a few minutes. These deserve like hours and hours, and I don't have it. But I want to talk about how to make advanced material. So I will give you like few advanced materials. Because, for example, if you remember now, I mean, my gold was a bit different. And now I should find the folder. For example, the gold I was using had real roughness, so had like it's not like having increasing the roughness value, it's having a nicer, let's say, look. To do that, we should like really go deeply inside the properties of the material, and we have to open the shading option of Blender. When you click on shading, here you automatically open a completely different view in which you have these new things that we have never seen. These are nodes, because the material are actually programmed with nodes. For example, if now we go in Render again, you can see that here you have the principle that is the same that you have here, and all the material goes here. You can see that you have the output of the material and takes surface, volume, and displacement. Volume and displacement, no, please, not for now. Maybe I can, if someone is interested, I can explain what volume and displacement are, but later. Surface is what we're going to actually color now. What is nice of the shading viewport is that you can really have control on your mesh. Let's say on how your mesh looks. For example, let's take this object and let's take a new material. So let's take this new material. Okay, let's say that this material is red. And here I can use all the shortcuts that I used before. For example, I can grab, move stuff, but I can duplicate object. So for example, I can say, I would like that my material is a red material combined with a blue material. And here I can combine shaders with the clicking Shift A, it opens a new panel with a lot of things. We will go through the very, let's say I will add some details of some of them. And here you see shaders that you have all the things you saw before. And if you click Mix Shader, it's a node, it's a box with two nodes as an input and one as an output. So you take the two shaders that you set it up, sorry, as an input, and then you have this factor value that is a knob to say how much of the first and how much of the second material you want on your surface. This is nice. You can also hide all the properties by clicking this small arrow here, and you can move it to make it nice. What is nice of this node editor is that now you can go inside the mesh detail. How? With the input value, you have both geometry and texture coordinate that practically does the same job. If you take the texture coordinate here in object, all of the others, I mean, for another time. In object, you have the, let's say, XY point on top of the, let's say, on each face, you have XY point on each face, okay, and XYZ point. And here you can access the detail of those. I will try to be more specific. In practice, you can say that you have an image, a white-black image, and this is, and you have your object that is, let's say, unwrapped, opened on top of this image. And then you can calculate the XY value on top of this image. What it means is that if you give a white or black, you can give a 0 or 1 value to each point on the faces of your material. Again, I know it's, I mean, maybe I explained it really badly, I'm sorry. But why it's nice and how to control it. For example, here you have a very nice node that is in the converter, that is the separate XYZ. So if you connect the object to the vector, the input vector, now you can control this, the individual XYZ of your material. So if you can see that the factor depends on X, on the X of the material. So now you can see that half of your material, the left part of your material is red and the right part of your material is blue. You can also give more control on that by using, again, in converter, a math node. I hope I had not to explain what a math node means. No, I'm joking. Here in the math node, you have a ton of operations you can do. You can really build up a mathematical operation on top of your surface. So for example, if I add a value, I have now a knob to control where is the set point of the when it starts to be the other material. And so here, for example, I can do really whatever I want. I can take this value, I can duplicate these, and they can use these, and they can add those together to have something that goes in a diagonal direction. Or if I want, I can use the power 2. Power is actually, I mean, this is the base, this is the exponent. So what I'm doing now is I'm taking x plus something squared, y plus something squared, and then I'm adding them together. So here I have a circle, and this circle is movable on top of my surface. So by changing the different two objects, I, for example, can say that the blue part is actually transparent instead. And now I have a circle that can move on top of a cube by these knobs here. So with math, I mean, with the math node, you can really create whatever you want on top of each material you want, on each face you have. And this is only to explore. I mean, I have sometimes some nodes that are going completely crazy, but with 5 nodes making the map, you can have nice control. Another important node that it's let's say worth to mention is the converter color ramp node. And the color ramp node is practically something that takes a value from 0 to 1. I mean, it's taking a value, and where you can control with these knobs when it goes from 0 to 1. Or, I mean, you can also say that this is not really 1 by selecting the color. What does it mean, this? This is kind of weird in the sense that, I mean, you are using colors to set up numbers. When you put a color inside a number, it is only taking the this value here. So I think it's the modulus of the 3 numbers. I'm not sure, but if it's if all the 3 numbers are 0, then it gives 0. If the 3 numbers are 1, then it gives 1. And then here you can control, for example, how much you want to shrink your circle. But for example, you can add new point. Maybe it's very difficult to see here. You can add new point in the middle, and you can say that, for example, after a beat, you want to be black again. And then you have a bit of the material. You start with that material, then you go back to a transparent material for a bit, and then you go back to the previous material. And you can do it as much as you want. I have not enough time to finish this, but I'll try to be very fast. Here, you can really start, here you can really play as much as you want. You can go crazy. For example, now I can add some roughness to this value here, to the circle, okay? So I can take another math node, let's say an add math node, okay? And I can take a texture, and this texture is a noise. Let's take a noise texture. With the noise texture, we're going to tell him more or less the vector, the object that we have to calculate where, let's say, the real dimension of the texture that he's going to make. And then we take this factor and we add it to our object. Here it's going, this is probably too much because we don't see anything. Let's deselect this. Okay, with these two objects, it's really not very well visible. Let's do only this because now otherwise it's going too crazy. Okay. With this object here, with the details of the noise you are creating, you can control where you have one or another of the two materials that you made before. For example, with the scale, you can see now you have a small part that are the red that transit to, in a noisy way, to the blue mesh of the other one. And here you can add distortion of the material, so have like mess, or you can add details, and details is something that here we cannot see. Okay, so here is for mixing mesh and controlling the mesh that you want to mix. As you can see, the list of things you can add here is a lot. And I'm sorry that I cannot really go in the detail of this, but this is start to be advanced from now. What I can tell is that we are going to make the two materials that are actually important for us, that are an improved gold and an improved laser. How to do those? So let's take this material and call it cool rough. This thing is actually very nice for, I don't know, molecules or molecular stuff that you want, like, to give this look that is, let's say, noisy, but at the same time, let's say, give it precise colors and divisions. You can really, I mean, I don't want to go in details of this because, I mean, now you can do many things. Okay, let's take our gold that we did before. Okay, our gold looks okay, but as we said, the gold is really flat. And with this flat gold, I mean, you can make nice images for sure, 100%, but if you want some more realistic images, we should have like some roughness. And how can we fake the roughness of the material? The roughness of the material is, you can do it again using a noise texture, a texture coordinate, again giving object into vector. And here, instead of like doing as we did in the past lesson, in which we subdivide the mesh of the material and we use the displace modifier to add, let's say, roughness in the mesh, we want to do something that is really more clever, because we want to add roughness in the normal. In the sense, practically each face has a normal. And each part of the face, we can, let's say, tell to the software that each part of the face has a different normal. And we can give a different look to the normals of the material. This means that the light will scatter differently in different points of the material. And this is giving fake roughness. And the results are really amazing. How to do that? You can take a vector, a bump, and put the factor of the noise inside the height of the bump. Then the bump goes into the normal. Easy, then you can directly see that your material, it's already looking completely different than before. And by increasing a lot the details of your roughness, and maybe decreasing a bit the scale of your material, you can see that now your gold is looking completely different. I mean, the roughness is something that really can now, it's really nicer. You can control, for example, the amount of how much rough it is, also by controlling the strength of this bump node. And this bump, if you put the strength to 0, it's again the same gold you had at the beginning. If you put the strength to 1, you have the highest difference in normals. So this is like faking normals. And here you can see that here we modified the gold. And if you now go in the nanotube, you can see that now all the, it is very difficult to see from here, everything has this new golden material. You can also see that some of the part of our contacts has some problem with the material. That's because they are stretched. We scale them. And when you scale object, then also the noise that you're adding is scaled up. How to solve the problem? If you see this problem that things are stretched or the thing doesn't look how you suppose and how you want them to look, you can always do you control apply, control A, sorry, scale. If you apply now the scale, you correct the scale of the material, and you have a very nice golden contact. Okay. The last thing, because I have 5 minutes before ending, I want to give a nice shader to the laser. And here, what you can do is to change a bit the way it looks. Typically, if you think to a laser, it's not a, let's say, a cone of light only. It's more or less a cone of light, but it's like at the edges of the cone is, let's say, fading out slowly. I mean, then you want the laser to be in the center very bright and then more and more transparent while going to the edge of the laser. And to do that, there is a very easy way to do. You want to mix your emission with a transparent node. And now you see that you are emitting, but you can see through. But you don't want to do that. You want to do that on the edges only. You can start making the math to make it perfect. So to give a, let's say, a Gaussian profile to your laser, or you can take as an input a layer weight. A layer weight, actually, what it does is to take to weight the two options depending on how far are they from the edges and from the edges that you see from the view you have. Meaning that now, if you add this spacing to this factor, you can see that at the edge of the ball, you have less emission, and in the center, you have more emission. This one you can, increasing this blend value, you increase this, let's say, emission from the edges. And again, you can, if you are not satisfied with the results you have, you can always add a color ramp to decide how far from the edge you want the emission, or to, let's say, to tweak a bit this layer weight. But this is already more than fine for our purpose. Okay. So if we now look our nanotube, it is already set it up, I think. Okay. And the random-ish thing, it's already nice. And our laser looks better, I would say. I would tweak it a bit more, say 0.96. And now it's also even nice. Okay, I think I want to give a bit of a color to the fiber, maybe bluish. And then let's keep it like this because we don't have more time. Feel free, I mean, what you learned today, feel free to try to make new materials and to change everything we made. And once you set it up your material, you can go back in layout. Once you are in layout, you can finish your render. And to finish your render, you can go in render image. When you render your image, here it's using these values here. I mean, this engine here. And here is the number of iteration. So the samples is taking. How much time is integrating your render. This is, you can use two parameters. Let's say, let's not use the noise threshold for now. Two parameters to stop the rendering, the max number of sample or time in seconds. So for example, if I do now 120 seconds, it's 2 minutes of rendering. So it's like a fast render of your image to see how it looks. And then if it looks fine, you go with like, I don't know, 20 minutes of rendering. Here are the properties of the render. So the resolution you want. Here in this panel here, they're already set it up, all the resolution, typical resolution of images, the 4K, HD, vertical, HD, horizontal, etc. Here, if you want already to save it somewhere or no, and the way you want to save your image, if in PNG, BMP, or JPEG. And to finish, I think the best thing, actually, to have a render, you should have a camera. So you need something to photograph your scene. So to add a camera, you can click Shift A and add a camera here. So now the camera is here, but once you have, for example, then the view you like, for example, this one, you can click Ctrl-Alt-0, and then your camera will take a peek. You will go in the view you have now. So for example, you can then adjust with grab your camera and move it around. Or here with the focal length to zoom in or zoom out the view. Another important thing that you have to do to use before rendering is the background color. So for example, here there is your image, and you can here the background is black, but maybe you want it gray or you want it whitish to have like more light in your image. Or if you want to put it on a paper or somewhere that it needs a transparent, let's say, background, you can do it here in film transparent glass. And then now you're rendering with a transparent background. So now you have your camera, your materials done, everything is set up, and you are free to start rendering your image. And if you click render, you will see that it starts rendering your object. And here it's saying like how much time it's remaining, etc. Once the render is finished, you can directly click on image and then save your image wherever you want. And I think that that's all for this short workshop. I'm sorry that I went a bit fast for the last 10 minutes, but it was, I mean, a lot of things that I wanted to say in 1 hour and a half, and I really try to do my best. If there are any questions or anything you want to tell me, please feel free now. And that's it. You have now a way to make your own 3D images.
Cool. So I will share all the recordings on, like in an email, including all the videos and then all the links that Matteo already sent to all of you. I also that's okay. So, thanks, Matteo.
Thank you all that arrived until the end, and it was, I mean, it was really nice for me to try to explain for the first time Blender to someone, and really many thanks for also to Icons for organizing the course. It was really helpful. And yeah, anything in, I mean, wherever you will have any images or any render, I really would like to see if you also have this this render here that we made together. If you have your own and you made your own, please send it to me, because it would be really interesting for me to see if you personalize your own render. And said that, thanks a lot again to everyone.
To you.
And see you outside for a beer.
Yes, exactly. Social Friday time. Thanks, Matteo.
Bye bye, guys.
Thanks, Matteo. Bravissimo.